All right, so I want to do some additional examples from section 3.5, and these are examples, these are all from your textbook, and you will be doing some problems similar to this. So on this first one on number 32, they give you tables to represent the functions f of x, g of x, and h of x, and you're asked to write g of x and h of x as transformations of f of x. So we need to kind of compare. I'm going to start by comparing f of x to g of x to see what's different. Notice the y values don't change, but the x values do. So to get g of x, we're going to subtract 1 from each x value in f of x. So we're subtracting 1. Think about a number line. If you subtract 1, you're going to the left. So we're going to go to the left 1. So then you think about, how do you write that if you are going to move to the left 1? Well, that's going to be f of x plus 1, because remember, if you're moving left or right, it's inside with the parentheses and with the x, and it's the opposite direction. So we would get that. Then for the next one, we're going to compare f of x chart with the h of x chart. And notice on this one, the x's don't change, but look at the y values. The y values decrease by 1. Well, if it's decreasing, then it moves down 1. So think about what transformation would make that move down 1, and we get f of x minus 1 with that minus 1 on the outside. All right, on this next problem, this is number 36 from your textbook, and it says to write an equation for each graph function by using transformation of the graphs of one of the toolkit functions. I had given you a printout that was from your textbook that had all the toolkit functions. Parent graphs is the parent graph toolkit. We had in Algebra 2. So when you look at this, and I'm going to give it a different name, I'm going to call it g of x for my parent graph, is the absolute value of x squared. I'm sorry, the absolute value of x. So we know we have a v-shaped graph, so we have the absolute value of x. So when you start to look for how it's been shifted, I kind of started to go through this problem and then caught an error that I made. You have to make sure that you look at the scale, because notice the horizontal axis is counting by 1s and the vertical axis is counting by 2s. So the vertex of the parent graph would be 0, 0. So for my function f of x, the vertex of f of x, you might look at it and go, oh, negative 2, 1, but it's not. It's negative 2, 2. You got to pay attention to that graph. So that means it shifted to the left 2 and up 2. So I'm going to write that down. Left 2, up 2. Then we also need to consider the slope or steepness of my V-shaped graph. So notice from here, if I go up 2, I go over 2 to get to the next point that's on the grid. So up 2 over 2 just means it's really a slope of 1, so it's not stretched or compressed. So not stretched or compressed. So that would be the trickiest part of that one would be if you didn't pay attention to the scale. So then f of x is to the left 2, so that's going to be an x plus 2 on the inside, and then up 2 is going to be a plus 2 on the outside. So watch out for that, the scale. All right, for this next one, hopefully you can look at this and recognize that g of x, I'm using g of x for my parent graph, would be x cubed. And just as a reminder, I'm going to just kind of put a little sketch here. From 0, 0 would be on there. If I go over 1, 1 cubed is 1, 2 cubed is 8. Okay, it's going to be way up here somewhere. So I'm just going to kind of, we've got something that looks like this. So we know that's going to be our graph. So we have to think about what has changed. So I can tell that my point of inflection, remember it's not a vertex, it's a point of inflection. And I can tell that my point of inflection is not at 0, 0. It's at the point 2, 1. So that's important. Because that tells me how it's moved. But I can also see that it looks like it's flipped. So it appears, so first of all, it's going to be to the right 2, since it shifted from 0 to 2. And it's going to be up 1. So we know that part of it. But we can also look at this and say that it's flipped over the x-axis. Okay, so because if you look at what I had here, imagine flipping that over the x-axis and then moving it to this spot. So when I write down f of x, I know that I'm going to have the x minus 2 quantity cubed, because remember this part goes inside and it's the opposite direction, plus 1. And then if you look back at your chart, what change is made to the equation if it's going to be flipped over the x-axis? And that would be by making this negative. So this would be my function that would produce this graph. And you can always verify these on the calculator. All right, for these three, for the following exercises, write a formula for the function g that results when the graph of a given toolkit function is transformed as described. So the graph of f of x, and I'm going to do this a couple ways. I'm going to show you with the using the chart and how f of x changes, like without this, and then we'll substitute it in and call it g of x. So if you are going to reflect over the x-axis and horizontally stretch by a factor of 2, if you look back at your chart, reflecting over the x-axis means that I put a negative sign in front of the f of x. And if I'm horizontally stretching by a factor of 2, remember this is the one that you have to think of backwards. Look back at your chart. What does it mean if it's horizontally stretched? So what I would end up doing is I'm going to have a negative f of 1/2 x. If we didn't know the function for f of x and all we knew was it's reflected over the x-axis and horizontally stretched by a factor of 2, we would write this down. So that's, remember that this 1/2 goes inside with the x, not on the outside. On the outside is a vertical stretch or compression. On the inside with the x is a horizontal stretch or compression, and it's the opposite way of that you might think. But since we do know the function, and I'm going to call it g of x. And what you do is you're going to make it's going to be negative, and it's the square root of x, but we're going to replace the x with 1/2 x. So it's the square root of 1/2 x. Or you could say negative the square root of x over 2. That would be the same thing. So that would be g of x, since we know particularly what the function f of x was. So on the next one, the graph of f of x equals 1 over x is vertically stretched by a factor of 8. So think about where you place the 8. That's going to be out in front of the f. And shifted 4 to the right, well, that means it's going to be an x minus 4 and up 2. Okay? So that is going to vertically stretch by a factor of 8. So when we write it out, g of x, I'm going to have an 8 times 1 over x minus 4, because I'm replacing the x with an x minus 4, plus 2. Or I could write that as 8 over x minus 4 plus 2. So that's when we know exactly, in particular what that function is. And for the next one, the graph of f of x equals x squared is horizontally stretched by a factor of 3. So that means I'm going to have to use a third and that it's going to go inside with the x. Then it's shifted to the left 4 and down 3. So that's in terms of f of x. But in terms of g of x, we're going to take our function, we're going to have a 1/3. We want to shift it to the left 4, and then we're going to subtract 3. Wait, to the left 4. Sorry, that's a plus. And then down 3. So technically the question that was asked, this is your answer. Either one of those. Okay, I just wanted to show you, because sometimes you don't know what the function is and you're just asked to leave it in terms of f of x. So I wanted to make sure you could do that. And then the last one I wanted to do is number 72, and we're given k of x equals negative 3 times the square root of x minus 1, and we're just asked to describe the transformation. So what do the things do? So we're going to vertically stretch. It's vertically stretched by 3. By the way, it's important that you say vertically stretched and not just stretched, because now we have horizontally stretched as an option, so you have to clarify. Vertically stretched by 3. Then the negative sign is going to make it reflect, so it's reflected over the x-axis. And then that minus 1 makes it go down 1. And that's it. So these, I just wanted to do some examples because I know some of these are a little bit different, and so that you would be successful with your next assignment.